Okay.
Hi everyone. Welcome to Ken Shoulders number 16. And today we've got a really great one, and we have Lacey reading it to us, and she's going to share the screen and the stuff with us. So
Yeah.
yeah,
Okay. I'm gonna have to zoom in.
yeah.
Microscopic radiological treatment using EVOs by Ken Shoulders. Abstract. A non-invasive radiological treatment and analysis method having characteristic dimensions in the 10 micrometer range is proposed. The method is based on the use of EVOs swept in a three-dimensional array by both angular deflection and timed excitation to cause local disintegration without disturbing material previously transited. This disintegration gives rise to highly energetic electron emission for treatment and diagnostics, as well as wideband electromagnetic emission used as a location marker. Data is made available on known guidance and trigger variables and limitations, as well as errors found in measurements made in several nuclear energy assessment methods. Background for the work. Although the basic EVO work for this device was done by Ken Shoulders and largely published on the web at length, the preponderance of the data for this present essay are derived from the excellent Russian work published in references 1, 2, 3. These references cover both the physical experiment for producing and measuring strange radiation, as well as the biological effects produced by the radiation. Reference 4 and 5 by Ken Shoulders, available for download at the above mentioned site, render an interpretation of the strange radiation as having an EVO origin that is capable of both nuclear transmutation and teleportation by being able to penetrate matter due to the almost total suppression of express charge for the ensemble.
Wow.
Basic description. The proposed technique begins with the generation of EVOs of a size appropriate to the end result desired, with small ones being used for diagnostics only, while larger ones are used for both diagnostics and radiological treatment. A convenient range of sizes lies between 0.1 micrometer diameter and 20 micrometers in diameter. A single source, a line of sources, or an array of sources can be used. The repetition rate of the generator can be in the range of 100 millihertz,
Megahertz.
megahertz,
Yep.
if good generator technique is used. The generated EVOs are allowed to subside or cool to a black state, capable of penetrating material with only minimal interaction. The formation is then swept electrically while at atmospheric pressure, just as electrons are swept in a vacuum. This essentially forms a two-dimensional array of EVOs with some assigned velocity ranging between near zero to near the velocity of light. In the next step of preparation, it is necessary to find and incorporate some yet undefined process, preferably using an internal timing mechanism like those shown in Figure 13 and 14 of reference 6 and Figure 7 and 10 of Figure 7. Figure 13 and Figure 14 shows an internal timing mechanism causing a propulsive side thrust, while Figure 7 and Figure 10 shows a timing process causing the disintegration of the EVOs into high energy electrons, ranging in energy to over 50 keV. Getting an understanding of this internal timing process is key to making a successful instrument, as that is what determines the resolution of the three-dimensional aspects of the two-dimensional swept fields generated earlier. As the EVOs are explosively disheveled sequentially, a wideband electromagnetic signal is generated, helping to locate their position by using timing from the pickup electrode array. In addition to the electromagnetic signal, a burst of pinpoint X radiation is created, having the characteristic line emission of material near its location. This allows for both chemical analysis and density analysis of material beyond the region of emission from the point source by image projection, a well understood technique. However, the absorption of this low energy radiation is expected to be very high if much biological material is penetrated. A wide range of methods that are commonly used in other instrumentation can generate images of the volume being diagnosed and treated. It is likely that a preferred plane of imaging be selected due to the elongated nature of a typical EVO explosion. The best image would be found along the longitudinal direction being traveled. Cross sections are naturally generated in the imaging method. Oh.
Wow.
EVO guidance. Although the initial aiming accuracy from the EVO source is very good, once an EVO has entered the target mass, there are aiming accuracy considerations that lie beyond the scope of knowledge at this time. As already alluded to, the origin and nature of the internal timing methods of an EVO are also virtually unknown. There are known guidance factors that present a potential hazard to the resolution of the method proposed here. Among these is the ability of certain dielectric configurations to completely capture and guide EVOs. An example of this is shown in figure 6 of 3 on page 13, where a radiographic film used for recording the passage of an EVO captured it within the thin emulsion layer. It is far from likely that this long run with the emulsion was due to accurate alignment with the source. This class of guidance has been seen repeatedly in prior EVO work by the present author. Although such specific guidance is not good for the presently intended usage, it might have application to special forms of diagnostics not yet discovered where biological channels serve as EVO guides. There is a wide range of velocities that can be selected for EVO propagation. The launching velocity can range between practically a standstill to near the velocity of light. Which velocity will be best for actual diagnostic and treatment use is yet to be determined. One must keep in mind that the velocity is not the mediating term in interaction so much as the degree of the gray EVO state used.
Mm-hmm.
Radiological treatment. Reference 1 gives the results of radiological treatment on mice placed near the electrical discharge experiment used in most of the work performed. The summary of that work, as stated by the author, is number 1, strange radiation that results from the explosion of
Titanium.
Explosion of titanium foils in water and other aqueous solutions has the capacity to produce biological effects. Number 2, biological effect of strange radiation is manifested by an increase in the number of nucleated cells in the bone marrow. Number 3, strange radiation leads to an increase in dividing cells in bone marrow. Number 4, strange radiation resulting from 10 explosions carried out within 3 days after exposure to gamma radiation, 6GY, leads to a decrease in bone marrow repopulation. Number 5, assessment of the rate of micronuclei in bone marrow erythrocytes did not reveal any genotoxic effect of strange radiation. Number 6, exposure of mice to strange radiation leads to 1.5-fold decrease in genotoxic effect resulting from additional gamma irradiation, 2GY. Such reaction may be described as an adaptive response. Number 7, exposure to strange radiation can bring about an increase in the proportion of neutrophils in the peripheral blood of experimental animals. Number 8, it can be suggested by the results of the test exposures that strange radiation can affect human health. Number 9, it has been shown by these preliminary studies that to gain more insight into the biological effects of strange radiation, further investigation would be necessary. It is the opinion of the present author that the radiation effects seen were caused by high energy electrons resulting from EVO breakdown and not a result of X-rays or other forms of actual radiation. In general, the emission velocity of electrons from EVOs decomposing from an active white state lies in the range of 2 keV. More explosive EVO states can cause electrons to be released above the measurement limitation of 100 keV. The size of the EVO can be varied over a very wide range, and it is possible that a small enough size can be used that greatly minimizes biological materials destruction in order to allow benign diagnostics to be used before treatment. Cold fusion nuclear measurement errors. Many nuclear measurement errors are possible in the presence of the deeply penetrating characteristics of EVOs. The errors stem from the use of energy dispersive measurement and absorption methods being used instead of wavelength dispersive techniques. Crystal detectors, some scintillation methods, and CR39 nuclear detectors should not be used as they make a gentle EVO passage look like a cosmic particle event. On page 15 of 2, EVO-like particles measured on 2 plastic scintillation detectors as moving at V 20-40 milliseconds.
Meters per second, I think.
Meters per second.
The squiggly line,
Registered,
it means approximately. So it's saying velocity approximately 20 to 40 meters per second.
Yeah.
registered an energy of
Approximately.
Yeah, approximately 700.
the
Big M's 1,000, little M's 1,000. So like, I don't know. I think actually M's. I think they actually use it for mega. I think it's 10 to 6. I think you're using the K. Big K mean 1,000. Big M mean 10,000. That's a lot
Yeah.
of energy. About seven. I'd be 700 million electron volts is actually I think that means.
the approximately 700.
I believe they're using Big M for because he's pretty consistent because you saw KeV that means 1,000 electron volts. I'm pretty sure sometimes you see Big M as just mean 10 to the 6, aka a million.
Yeah.
On RF ZMP fluorographic film detectors. With EVOs, velocity is not the best indicator of total energy content. Bent crystal spectroscopes and spectrometers should be used to measure radiation whenever there is doubt about the presence of EVOs. The resulting errors in measurement have led to many bad assumptions in the work associated with plasma focused machines and in cold fusion technology, where EVOs occur profusely. These errors are at the root of the arguments over the origin of cold fusion energy production and transmutation. With the EVOs present, nuclear transmutation is almost always present, and these EVOs are the root cause of the excess energy produced. And then it references 8. No energy release has been directly traced to the transmutation process itself.
Wow. There's a lot going on there. I was going to go back to the first page because what was he talking about here? Where they start talking about the EVOs going from like the white state to the gray state to the black state. And in here, he's talking about how when it goes to the black state, it's actually cooling. it's cooling the EVO. So that's kind of an interesting something that came up. And we know from Chris Beskar, he's told me that we can de-radiate nuclear waste within 48 hours using charge cluster EVO technology, right? So this is kind of talking a little bit about that. There's pretty amazing stuff here. And the last statement was pretty incredible when he says, with EVOs present, nuclear transmutation is almost always present. That's wild. That's a wild statement. And that's why the Proton 21 laboratory that was in Russia originally, they they proved that shooting an EVO through a copper slug causes transmutation on the other side, essentially. So it's something to do with these changing it from the white state to the gray state to the black state, essentially. Yeah. Um, and Lacey and I have another interview with Chris Vescar coming up really soon. And I think that might be one of the questions that Lacey was going to ask him, actually,
Yeah,
about
yeah.
the process to go from white to gray to black and what's all involved with it. Um, I guess one thing to know that Ken Childers' cancer was probably caused by EVOs. So that's why we're going through and trying to figure out exactly what's going on here.
Mhm.
And we're going to do more research into it all. Yeah, so very cool. Does anyone else have any comments?
Well, we were talking about gamma ray, gamma radiation, and when you get actually like at the point of creation, and this is true, they even say like when a sperm fertilizes an egg, there's actually a little burst of light. Every point in creation, at that very point where things like born, there's a flash of light, and it happens even in the galactic centers, but it happens even in the tiniest things, like even on electrons and things like that. And the reason, like, tiny amounts is not a big deal, but when you start to get, massive energy manipulation, which almost for sure he's talking about, some of like like to make these things, like to make an EVO generator, you want to make it really powerful, and you're going to have things that are pulsing pretty
Yep,
high
yep,
frequencies control and things like that. You get that too close to you know creative things and stuff like that, like in your bones and stuff like that, where your stem cells are. I mean, absolutely, that's going to tend to warp things a little bit. So you got to be careful with this stuff.
yep, exactly. And that's exactly why we're doing this, going through all this research is to figure out how to do all this safely, essentially.
Mm.
That's, yeah, the biggest thing, definitely. Yeah, very, very cool. And the radiologic treatment. So it's interesting because he talks about strained radiation a lot here in this and how it can interact with, like you're saying, human cells and whatnot. But the velocities is very interesting as well. The velocity can range between practically a standstill to near the velocity of light. And I'm wondering if if when they're spun up, that's probably when they're the most dangerous, and maybe that's when that strange radiation is occurring. But that's again a question for Chris Beskar, essentially, because Ken Shoulders was Chris Beskar's business partner back in the day before Ken passed away. So yeah, very cool. Well, all
Hey,
right.
Con,
Do you want to maybe stop the recording, Lacey, and we can talk about some more stuff?
Yeah, yeah, for sure.